Objective 2 is operations on functions. I'm going to have you within this objective do 3 different operations. We're going to do multiplication, we're going to do addition, and we're going to do subtraction. And this is going to call upon your previous knowledge of what a term is, how to combine like terms, how to distribute, those types of things. All right? I'm going to do an example, number 7, then I'm going to have you pause the video and you're going to try number 10 on your own. And I've listed the steps out in my thought process in red in between these 2 problems. So please follow along step by step and show your work exactly like mine. If I was given number 7, I would first read the directions. It says perform the indicated operation. And I say that it says find, or I see that it says find g of x times h of x. So I know that we're dealing with multiplication. So the first step of this process, if I was going to solve this and model how to do so, is I would rewrite the functions, put each of these functions inside of parentheses with the given operation in between them. So my first step will look like this. My first function is g of x. That is, right here, negative 2x minus 5. Right there. Then I'm going to multiply it with h of x. And again, with multiplication, when you're working with parentheses, you can just write them right next to each other. H of x is x squared plus 5x. Alright, I am done with step 1. I rewrote it so that I could actually visualize what I'm doing in the next steps. Step 2 then states, perform the given operation, reading from left to right, depending on what the operation is. In this case, again, it's multiplication. So for step 2, I'm going to do something called distribution. And again, that should be previous knowledge from Algebra 1. Distribution, you might hear this first term times first term times second term times first term, second term times second term. I'm going to write out that process as I do it, because that is the way to go about this. The first term of my first binomial is negative 2x, so I'm going to put negative 2x down here. I'm going to multiply that with the first term of the second binomial, x squared. And I'm going to draw pathways or archways that connect the pieces that I'm multiplying together. That's going to give me a new answer. Then I go back to the first term of my first binomial, which is negative 2x. And I'm going to multiply that with the second term of the second binomial, times 5x. Now, I'm done with the first term of the first binomial, negative 2x. I move on, and I'll switch colors, to the second term of the first binomial that I haven't done anything with yet, which is negative 5. I'm going to multiply this with the first term of the second binomial, x squared. And then I'm going to multiply negative 5 by the second term of the second binomial, which is 5x. And it's going to give me 4 new answers. Now, if you notice, there is a pattern here. I have x squared, 5x, x squared, 5x. They repeat themselves, depending on how many terms exist in the first parenthesis. In this case, there's only 2. So, in order to do the math in step 2, and again, I really emphasize that your work in step 2 should look exactly like my work in step 2. If you write it out like this and show exactly your thought process, I almost guarantee that you will completely minimize any errors, mental errors you would do with this math of the multiplication, because you're actually looking at what you're doing. So for step 2, it says, again, perform a given operation. The first operation is negative 2x times x squared. If you remember, when we multiply terms together, I have to identify coefficients and variables. The first coefficient I see is negative 2. I'm going to multiply that with the coefficient of the second term of x squared. It isn't written, and whenever this is the case and it's not written, I can assume that the number or the coefficient that exists in front of the x squared is a 1. So now I have negative 2 times 1 is negative 2. Moving on to the variables, I have an x in the first term and an x squared in the second term. These variables are considered bases, and every base has an exponent or a power with it. In this first one, negative 2x, it isn't written, and again, whenever a number isn't written, I can assume that it's 1. So now I have variable times variable, or base times base, and if you remember from Algebra 1, when you have a base times a base, you add the powers, or the exponents. That is a rule you need to remember. You add the powers. So x times x squared, 1 plus 2 is x to the third. And I am done with the first set of multiplication I need to do. Moving on to the next one then, negative 2x times 5x. I look at the coefficients, I have negative 2 times 5 is a negative 10. And then x times x, each one has a power of 1 because it's not written. X times x, base times base, you add the powers. 1 plus 1 is x squared. Done with that second piece. The third piece then is negative 5 times x squared. Again, the coefficient of x squared is 1. It's not written, but I know that to be true. And if you notice, negative 5 doesn't have a variable. It's just a number or a constant coefficient. So I'm just going to take negative 5 times 1, which is negative 5. And there's nothing to multiply with x squared. And so I just bring x squared along for the ride. And then finally, negative 5 times 5x. Negative 5 times 5 is a negative 25. In similar situation, this x doesn't have anything to multiply with over here, so I just bring it along for the ride. I am done with step 2. I can put a check mark. Now, step 3, I'll switch back to green. Step 3 says combine like terms if necessary. You won't always have to do this step. In this case, you do have to do this step, all right? And what jumps out at me when I'm doing this problem is like terms. I look to see if there are any like terms between these 4 that I just found. And if you remember, a like term is a term that has a variable with the same power. So if I look, I have an x cubed, I have an x squared, I have another x squared. I have a negative 10x squared and a negative 5x squared. And then I have an x down here. So because these two terms have the same power, they're considered to be like terms. And I have to combine them together. Now I'm going to show this math over here. I have a negative 10x squared, and I'm adding a negative 5x squared to it. Alright? And when you're adding terms together, the powers don't change because they're the same power. Alright? They only change when you multiply terms together. When you add or subtract terms together, they do not change if they're like terms. So negative 10x squared, so I know in my answer I'm going to have an x squared. Negative 10 plus a negative 5 is a negative 15x squared. So these two terms over here combine together to form negative 15x squared. And again, I know that I needed to combine them because they were like with each other, meaning they had the same power. They had an x squared and an x squared. So, finally then, so I did step 3. Step 4 is to write in standard form. And standard form means you write the highest power first, and then write it in descending order. So the next highest power, all the way down to just a coefficient if you have one. So my highest power, if I look at all 4 terms that I have, is negative 2x to the third. So this is step 4. I have negative 2x to the third. Moving down the line, I did have negative 10x squared, negative 5x squared, but that combined into negative 15x squared. And because it's negative, I'm just going to write minus 15x squared. And then finally, my last term that I did math with is over here, negative 25x. So I write minus 25x. This is my final answer. Please square and put a check mark next to your final answer. So at this point, I'm going to ask you to pause the video and try number 10 on your own. It is very similar. It's a multiplication problem between 2 functions that are binomials to the one I just did. So please pause it. I'm sorry, before you pause it, I want to make one note. Step 3 is going to look a little different than number 10. Please see if you can come up with what is the difference between the two, and then move on to step 4, see if you can write it in standard form. So at this point, please pause the video and try number 10 on your own. At this point, you should have paused the video and tried number 10 on your own. Here are my 4 steps that I did to solve this, so please check your steps with mine, and then check your answer in step 4 that I've squared and put a check mark by. If you didn't get the same answer as mine, or if there's any step that doesn't look necessarily the same as mine, please raise your hand so I can come by and check your work with you. But again, my thought process. First step is I wrote it out, just like I did in step 1 over there. Step 2 is I did the actual distribution. I multiplied everything. First term times first term, n squared times n is an n cubed. First term times second term, n squared times -2 is -2n squared. Then second term times first term, which I wrote in purple, 4 times n is, I'm sorry, not 8n, it is 4n. It is 4n. And then finally, second term times second term, 4 times -2 is a -8. Step 2 is a very important step, so please check your work with mine and make sure it looks like that. And then this is the difference that I ask you to notice from number 7, the problem I did, versus this one. In this case, between these 4 terms, right here, there are no terms that are in common with one another, meaning there are no terms that have the same power. There's an n cubed, an n squared, and an n, but none of those are the same. So I don't have to do step 3 in this case. There's no like terms to combine. So I can skip step 3 and go right on to step 4. Finally, writing in standard form. If you notice then, step 4, this has 4 terms in its answer because I didn't combine 2 of them to become 1. Where over here, it had 3 terms because these 2 terms, the middle 2 terms, were the same, so I had to combine them. So you should have gotten n cubed minus 2n squared plus 8n minus 8. Again, if you didn't get that for your answer, please raise your hand so I can come by and go over it with you. In the next video, I'm going to do example 8 and ask you to do example 9. And if you notice, example 8 is the operation of subtraction.